we'll start off with some that you know, and then have a look at some that you'll need additional tools to work with in order to understand better. And by the way, this topic highlights how 3 unit and 4 unit, right? There's a real sort of relationship between them. When you do 4 unit topics, it really helps out your extension 1. Have a look at this. Rational polynomial, linear denominator, and importantly, the numerator has the same degree as the denominator, okay? In fact, as you'll see later, if you experiment with it and have a look at some of the exercises, it won't matter if the degree of the numerator is higher, but it needs to be at least equal, okay? How do I manipulate this so I can put it in a form that I can integrate? Any suggestions? What could I do with it? Anyone confident enough to actually say, because I heard some murmurs, but anyone have a go? What would you actually do to it? Here's the clue. What you really need is to get the numerator somehow in the form of, or in terms of rather, the denominator. Okay? So at the moment the numerator is in terms of x. I want it in terms of 2x plus 1s. How many 2x plus 1s can I see in the numerator? Hopefully in about 2 minutes you'll be able to tell me why that's a useful thing to do. So here's what I'm going to do. First, I can see the important part is the x. Right? The constant, I can plus or minus constants and they'll come out in the wash. Okay. How many 2x plus 1s am I likely to fit into the numerator? How many of them? I'm thinking I'm going to get about 1.5 of them, right? Not exactly because the constants are different, but let's try that out. So 1.5 of those, okay? Now if I have 1.5 of them, okay, that's not exactly the same, is it? It's not going to be 3x minus 2. What is it? It'll be 3x plus 3 over 2, okay? So I have extra stuff on the top, stuff I'm not meant to have. I need a minus 2 there, right? So what I'm going to do is I'm going to subtract something to compensate so that I get back to my minus 2. What should I subtract? Minus 7 over 2, I think, if you do the numbers right. If I take 7 over 2 from that, you get negative 4 over 2, which is the minus 2 that I started with. Okay, so good. I've got the numerator in terms of the denominator. And there it is. Now, you tell me, what was the point of that? Why is that a useful way to simplify this? I can do some cancelling here, can't I? I can separate these fractions out. That's handy. Okay. So here's one fraction. The 2x plus 1 here and the 2x plus 1 here will just cancel. So you get 3 over 2. Okay. And then you get 7 over 2 lots of this. Okay, 3 over 2, you can integrate that. What's that thing on the right-hand side? When you integrate that, what is that going to be? It's going to be a log, isn't it? Just to make it a little more obvious, to be a log, you need f dash on f, right? You don't quite have that, do you? Right? What is f here? It's just 2x plus 1, isn't it? So f dash really ought to be 2. Right, now you can see the f dash and f very obviously. But of course you can't just go in putting 2's where you want because it's convenient. If I multiply by 2 here, I suppose I ought to divide. That would turn that into a 4. Is that alright? See what I've done? Now I can integrate. Just slap the x on, and this of course will become 7 over 4 log of. Lost constant. Great, no problem. Okay. Again, the critical step is up here, and maybe you even want to make note of this, right? It's to get the numerator in terms of the denominator. Okay? That's what lets you do this step, which simplifies out and gives you something you can work with.